All right, let's go ahead and look at another example. In this example, we're told a stats class took an exam and 20 students had an average or mean score of 92% on that exam. Later on, 5 more students took the same exam and they had a mean or average score of 80% amongst those 5 students. So with this information, we first want to calculate what is the mean or average for the total class. All right, so we want to find the total average for the exam scores of this class without knowing the individual exam scores for any of these students. And so that's what the useful concept of the average or the mean is we can replace all 20 of these students with an exam score of 92% for each student, and that now the sum of that data is going to be the same. It doesn't matter if some of those students scored above or below 92, but if they all acted like they did score 92, then the data can be worked with in the same way. Similarly, we know we have 5 students who, whatever their exam scores actually are, if we replace them with 80, then the sum of the data is remaining the same. So if we want to find the mean or the average, we just have to sum up all of these values and divide by the total number of values. For this first group of 20 students, we can kind of pretend that each of them scored a 92% on the exam. So we don't need to write 92 plus itself 20 times. Instead, we can take that frequency of 20 and multiply it by our data value of 92. Then we have to add to this the rest of these students' exam scores, or their average exam scores that is. We have 5 more students and they averaged out an exam score of 80% amongst those 5 students. So we have to add 80 to this sum 5 times, or 5 times 80. Again, just the frequency multiplied by the data value. And we have to divide this by the total frequency or the total number of students, which is 25. And that'll calculate the mean or the average exam score for this group of 25 students. All right, so when I calculated this mean or average exam score, I found that the mean or average exam score for these 25 students was 89.6%. But we're not quite done with this example because I have a couple follow-up questions I want to look at next. All right, so the 2 follow-up questions I have that'll help us kind of work with this mean or average formula a little bit is question 1, if 2 students dropped the class who had exam scores of 89.6% each, what would the new mean or average exam score for the class be? And then the next follow-up question is, what if those 2 students who dropped the class actually had exam scores of 60% and 85%? How would that affect the class average or the class mean? And we actually shouldn't need to do any calculations for this first follow-up question. We found that in this group of 25 students, the average score was 89.6%. And so that means if we treated it as if every student had a score of 89.6% instead of these potentially unique scores for each student, then the sum of the data values or the sum of these exam scores would be the same. So if we remove 2 scores that were 89.6, the sum of the exams would be 2 times 89.6 less, but we'd also be calculating the mean or the average over 2 less exams, and all those 23 remaining exams should still have an average score of 89.6. So if we remove 2 or really any number of students from this group where those students had that average exam score, that is not going to affect the average at all. It's not going to raise it or lower it because they were already at the average. So what would the new mean be? The mean is unchanged. The mean is still 89.6%. However, that won't be the case for the second follow-up question. Now, if these students who dropped the class had scores of 60% and 85%, that would change the average a little bit. Both of those scores are below the current average in the class. So if we remove them, then that actually means the average should go up a little bit. Now let's go ahead and verify that quantitatively. You can also, if you don't believe me, for that first follow-up question that the average remains unchanged, you can verify that quantitatively in basically the same way we're going to do part 2 here. Okay, so how can we see how the mean or the average is going to change if these students have their scores of 60 and 85% removed from the group? Well, we can start by taking the total sum of exam points in the group, which is that first numerator we calculated in that first mean. So we started off by having 20 students with an average score of 92%, and then an additional 5 students with an average score of 80%. We don't actually know what these students' individual scores were, but they can all be treated as if they had these scores of 92 and 80. That makes the sum of the data the same. Remember, there was 25 students in this initial group, but now we have 2 students dropping the class, so we have to remove their exam points from this exam point total that is our numerator. So we have to subtract 60 exam points as well as 85 exam points from this exam point total up here. And now we're not going to divide by 25 anymore because we don't have 25 students in the class anymore. We've removed 2 of the students, and so now we have 23 students remaining. And so if I did my calculation correctly, then if we compute this new mean that is found by removing these 2 exam scores of 60 and 85% from the group, then the average gets increased a little bit to 91.09 or about 91.1% on this exam.